In this example, we're going to look at something that is decreasing in value. So all the examples we've worked with so far, they were typically in terms of exponential growth. So we had some percentage being added on. So like in terms of accounts with interest, we were increasing the amount in those accounts. With this annual depreciation, we are decreasing the value. So for our formula here, we have this new notation, so FV and PV. So FV represents the future value, and PV represents the present value. So much like with the compound interest formulas we've worked with so far, PV, that present value, it's our starting value. So it's where the value begins. And then with our compound interest formulas, we were calculating the amount that it ends up with, which we called the balance. Here, that's just being replaced with this idea of future value. So it's what it's going to be worth in the future. But really, those ideas are the same. In the exponent, we have lowercase n. For this formula, that is going to be the number of years that have passed. And since this is annual depreciation, n should have those units of years, since that percentage should be working per year. Then R, let's talk about R. So R is the rate, so it's going to be some percentage. In a lot of the formulas we've worked with so far, we plug that in as a decimal. This is set up as a whole value, so I'll talk about that when we go through this example, but with that divided by 100 as part of the formula, it's kind of taking care of that decimal conversion piece. Another thing that's going to happen here is because this is depreciation, since our account is decreasing, when we plug in R, it should be negative. So if we had something that was appreciating, so appreciating would be increasing, then that rate is positive. If it's depreciating, then it's decreasing, and that's going to have a negative rate. Okay, let's apply this to this formula here, example. So we buy a new car for $24,000. It's depreciating at a rate of 15% per year. So how much is the car worth after 5 years? So what we have here is we have the present value of $24,000. That's what the car is worth right now. The rate is 15%. So what we're going to do is, because it's depreciating, we're going to make that negative, and then 15%. So we're going to use a negative 15. And again, in comparison to those previous examples, we were using like 0.15. Here we just use negative 15 because when we divide by that 100, that'll take care of that conversion to a decimal. All right, and then we have n equals those 5 years. Okay, so if we want to calculate the future value of this car, we're taking 24,000 times 1 plus negative 15 over 100 raised to the power of 5. So with that, we go to our calculator, and we'll have a future value of $10,648.93. So 10,648.93. So after 5 years, that would be what our car is valued at.